So students will convert between standard and vertex form of a parabola. They will also identify the characteristics of the parabola from each form. They will then use the graphs of the parabolas to solve quadratic inequalities and word problems. There are 4 basic conic sections, and we're going to try to get them all 4 this year, but the parabola is the second one. We've already done circles. Circle is your first conic section, and we'll talk about more what a conic section is when we get to the section or the chapter on conic sections. But today we start our second major conic section, that is the parabola. Here you see an example of 2 parabolas. Different parts of a parabola does have a vertex. That is the lowest or highest point on that parabola. A parabola has an axis of symmetry. All parabolas are symmetrical. Okay, so you're going to have some sort of axis of symmetry. Usually it's going to be a vertical line, so it's going to be like x equals some number. They also have a focus and a directrix, which we're not going to get into today. We might talk about that further down the road. But here you see, well, and something else. All parabolas open either up or down. Both of these opening up. And remember when we talked about transformations, because everything we do from here on out, transformations are going to come back into play. These parabolas are not flipped. Okay, the basic parabola is y equals x squared. That's the parent function, and it looks like this. These parabolas have been simply moved and stretched. Things that flip would be a negative out front. So you can actually look at this number right here, and if it's a negative, that thing's been flipped, or when it's in this form, if this a value is a negative, it's been flipped. There are 2 basic forms that we can write parabolic functions in. Standard form, and then this other form, there's standard form by the way, and this other form, they call it vertex form. Some books call it transformation form. But the reason they call it vertex form is, remember your different transformations. This minus 3. This minus 3, since it's on the x, takes this parabola and shifts it to the right 3 units. This plus 1 on the end takes this parabola and shifts it up 1 unit. When a function is written in this vertex form, as they call it, you can look here and you can look here and you can tell what that vertex is going to be. And you can look here to see if it's either stretched or compressed vertically. Okay. The first thing we're going to do is to actually teach you how to go from that standard form and to actually write something in vertex form. We do so by completing the square. Don't forget how to complete the square. I promise we'll be doing it this entire year. Okay, there's going to be things that pop up all throughout the semester. Oh, we got to complete the square again. So please don't forget how to do that. Here's your steps. Y equals x squared plus 6x. If there were a number being added or subtracted, we would have moved it to the other side. I think the next problem there is, but on this one, there's not. So next step, we're actually just going to go ahead and complete the square. If you don't remember, in order to complete the square, whatever number is in front of the x, you'll half it and you'll square it, and you add that to both sides. In this case, it is a 9. If you add it to one side, you have to add it to the other side. So you now have y plus 9 equals, we're going to factor. Help me with that, Lydia. X squared plus 6x plus 9 is going to factor into x plus, adds to give me 6, multiplies to give me 9, x plus 3. Or the easy way of doing it, when you're completing the square, it'll always factor into half of this. So x plus 3 squared. Last step, take this plus 9 and move it back over to this side. This is in transformation form. So now I have f of x equals x plus 3 squared minus 9. The parent function for all parabolas is x squared. That's the daddy of the parabolas. This is your basic x squared parabola that's been shifted a little bit left and a little bit down. Again, by looking at this, you can tell exactly where your vertex of your parabola is going to be. The plus 3, Daniel. Which way is the plus 3 on the x going to shift your parabola? Left 3, and the minus 9 is going to shift it. So if you take your basic parabola, which did have a vertex at 0, 0, you move it left 3 and you move it down 9, your new vertex, I don't think it asks you, but I want to do it anyway, is at -3, -9. So to graph this, honestly, you could go to -3, -9. Pretend like you're at pretend like you're at 0, 0, and just graph this. Go 0, 0. Go right 1 up 1, left 1 up 1. Go right 2 up 4, left 2 up 4. So that's an easy way of graphing this. Instead of having to plug in points, you could do that. Let's do another one. This one's ugly. Starting you out with that last one, a little bit easier. First step, anytime there is a number being added or subtracted, we're fixing to have to complete the square, so let's go ahead and move that over. So +3, when moved to the other side, is going to become -3. If there is a number in front of x squared, your next step, whatever the number is, whether it be a 5, 6, 7, 8, factor that number out. So we now have 2 parentheses, x squared minus 10x. I factored 2 out of both of those terms. What if that had been like a 9, though? You can't factor a 2 out of 9. Yeah, you can. You just get a fraction. You have to ask yourself 2 times what gives you 9. That'd be 9 halves, but I think we're going to work a problem in a second like that. Next step after you do that, you always complete the square. Help me doing that, Savannah. X squared minus 10x. Ignore everything else. Just x squared minus 10x. What completes that square? Plus, say it again, I'm sorry. 20, you was right. He was right the first time, 25. Plus 25. Half -10, you get -5, and square that, you get 25. If you're going to add it to one side, you have to add it to both sides, but be really careful. You added 25 in parentheses, correct? Did you add 25 to this side? No. If you were to multiply this back out, to this whole side, you didn't add 25, you added 2 times 25, or 50. That's the part where most people miss these problems if you want to star that step. If there is a number in front of those parentheses, in order to see what you added to the right side, because you got to add the same thing to both sides, multiply that back out, that 2 times 25, and see what you get. So now let's combine like terms. -3 plus 50 is 47. Let's factor on the other side. Anytime you complete the square, your very next step is going to be to factor it. Have me factor that, Abby. X squared minus 10x plus 25 factors into x minus 5 squared. Always factors into half of that, right? Everybody understand? And then your last step, move the 47 back over. You're now in vertex form. So y equals 2 parentheses x minus 5 squared minus 47. That's your new parabola. Again, it's in what's called transformation or vertex form. The reason we call it transformation, you can very easily see the transformations now. Your basic x squared parabola has been transformed. Noah, the minus 5, let's look for our vertex. Put a big V in front of it. The minus 5 is going to shift your vertex where? And the minus 47 will shift it, careful, down 47. So your vertex has been shifted from 0, 0. This is 0, 0 vertex. Vertex is the lowest point. Has been shifted right 5, so that'd be positive 5, and down 47. So your vertex of this parabola is 5, negative 47. And if you took those two transformations away, the only other transformation would be this, which would stretch it. You're not really interested in that. But this number 2 out here would stretch it twice as tall. So it'd be just tall and skinnier. Yes, sir.
So would you always have the x?
Yes, to factor it. Half and square to complete the square, and then your factored form will be half of it every time. Because you're going to ask yourself, what adds to give me this? Well, it'd be half of it, -5 and -5. And that same thing, if you did it correctly, those same two numbers should multiply to give you that. Okay. Parabola characteristics. Now, I've already showed you how to find the vertex, but what you've got here, somebody has done this job for you. Y equals 2x squared minus 12x plus 19 is this parabola. They wrote that in vertex form as well. This slide here is going to be extremely important to you. This slide here is pretty much going to sum up everything we're going to do in this section. Vertex. Let's start here. Looking at this, this equation, it's very easy to find the vertex. There's a way to do it. Let me go ahead and sum this up. There's a way to find the vertex if it's in transformation form, and there's a different way to find it if it's in standard form. There's a way to find the axis of symmetry if it's in vertex form, and there's a different way to find it when it's in vertex form versus standard form. In the opening, it's really easy. I'll show you what I mean by that. Okay, first off, the vertex. Brett, this parabola, and I know you can look at the picture, but let's do it from up here. This parabola has been shifted which direction here, Brett? Right 3, and so my vertex is at, careful, right 3, so 3, 1. And does everybody see that? That is my vertex. Right 3, up 1, there's the vertex. The axis of symmetry. Folks, the axis of symmetry is the line, and hopefully y'all remember this from back in 2nd, 3rd grade. An axis of symmetry, or a line of symmetry, is simply a line that cuts it perfectly in half. Okay, whatever shape you have. So a line of symmetry, there it is. For this parabola, notice it is a vertical line. Vertical lines look like this, x equals some number. How do you find the line of symmetry? Easy way? It's not just right there. The line of symmetry will always pass through the vertex. If it is a vertical line, it'll always share the same x value as your vertex. So your axis of symmetry is simply x equals 3. Don't put 3. On your test, 3 is not right. It has to be x equals 3. Because if you put 3, I don't know if it's x equals 3 or y equals 3. X equals 3, that's a vertical line. Y equals 3, that's a horizontal line. Here's y equals 3. That is not your line of symmetry. Okay? Opening. This one holds water. If it rained, it would hold water. This one opens up. Some parabolas open down, and we all know from our transformation chapter, what would force that to open down would be a reflection across the x-axis, which would be caused by a negative out front. So the easy way to see this, if the number out front is a positive, it opens up. If the number out front were a negative, it opens down. That's all you've got to do. Okay, now the other form. When a parabola is in standard form, it's easy to find the same 3 pieces of information. Let's start with opening. If the number out front is positive, it opens up. If the number out front is negative, it opens down. And again, these are simply the same 2 parabolas. We're getting the same information from 2 different forms. The next easiest thing to find is your axis of symmetry. Here's your formula. In order to find the axis of symmetry, if a parabola is in standard form, x is equals to negative b over 2a. I don't care if you put that on your formula sheet. The axis of symmetry for a parabola, x equals negative b over 2a. You don't have to, though, because let me show you where this actually comes from. I remember this formula, negative b plus minus the square root of b squared minus 4ac over 2a. That was the formula to find the solutions for a quadratic equation. Or if you had a quadratic equation, set it equal to 0, that was how you found the x-intercepts, which we're about to do again. That was how you found the x-intercepts of the parabola. But question, your axis of symmetry, let's say that this is negative 1 and 7 are your 2 x-intercepts. Does your axis of symmetry not go right between those 2 numbers? Y'all see that? Would it not be the average of those 2 numbers? Okay. How do you average this? That's two different answers. If you were to average it, that means you got to add it and divide it by 2. Do you see what would actually happen to this positive and negative here if you add them together? They not go away. And you would end up with negative 2b over 2a, but then you got to divide it by 2. Guess what you get? Negative b over 2a. So another way of remembering this formula, it's right there. It's the first part of your quadratic formula. Negative b over 2a is how you find your axis of symmetry. Let's do it though. When you have a parabola, here's your a, here's your b, here's your c. Notice that none of those have the x's with them. It's just the numbers. So negative b would be negative 12 or 12 over 2 times 2, which is 4, which is equal to 3. Your axis of symmetry is x equals 3. Reminder, okay, our axis of symmetry is x equals 3. Now, how are we going to find the vertex? Well, you've got half of it. Because the axis of symmetry passes through the vertex, so you already got the the x value of your axis of symmetry. How do you find the y that goes with it? Well, it's on the parabola. The vertex is right there. So in order to find the y value, plug in 3. You have 2 times 9, which is 18, minus 12 times 3, which is 36, plus 19. 18 and 19 is 37, minus 36 is 1. Same answer. So in summary, if something is in vertex or transformation form, here and here gives you your vertex. This gives you your axis of symmetry. If this is positive, it opens up. When it's in standard form, if this is positive, it opens up. Negative b over 2a tells you your axis of symmetry, which is also half of your vertex. The other half of your vertex can be found by plugging that x value in, and that'll give you your y value. Look at all the stuff this asks you to find. For each parabola, determine whether the parabola opens up or down, and find the vertex, find the axis of symmetry, find the range, find the maximum or minimum value of the function, and the intervals on which the function is increasing or decreasing. This is just a good review problem. Okay, let's start with whether the parabola opens up or down. Right there tells you. This parabola opens down. It'll be shaped like this. Right. Next, find the vertex. Right there's your vertex. This parabola has been shifted. Anna Marie, this plus 4 shifted at where? Left 4, and this minus 8 shifts it. So that'd be negative 4, negative 8. There's your vertex. The axis of symmetry, x equals, right there it is, negative 4. Because the axis of symmetry, again, passes through the vertex. It's a vertical line. The range of the function, okay, this seems hard. So we've got to plug in some x values to see what your range is. Now, use the graph. Guys, your parabola looks like this. The range is from down here, which I believe that would be negative infinity. It goes forever. From down here to up here. So the range of this function is all the values from, don't include negative infinity, all the values from negative infinity up to, does anybody know how high this function goes? There's your hint. Is that not the vertex? What's going to be the maximum y value of this function? Negative 8. And it does include that because that vertex is on the function. All the values from negative infinity up to this highest y value, which is right there, it's your vertex, negative 8. Domain, they don't even ask for domain. You can plug in anything for parabolas. There's not going to be a restricted domain. That's the reason they don't ask you. Find the maximum or minimum value. And the reason it says maximum or minimum, this parabola has a maximum. If it were cupped up, it would have a minimum. The maximum value of the function, you just told me, it's the highest y value. The maximum value of the function is negative 8, which again is right there. So it sounds like they're just asking the same questions over and over. And the intervals where the function is increasing and decreasing. Increasing, decreasing. And again, this goes back to last chapter. When you're talking about where a function increases or decreases, you're talking about x values. So this function increases, here it's coming up, okay, from this x value over here at negative infinity all the way up to this x value here. Okay, because at that point, at that vertex, it stops increasing and starts decreasing. But the question is again, what is that x value? It's right there. From negative infinity, from left to right, from negative infinity all the way to negative 4, it increases. And again, if you're checking your answer in the book, if that includes negative 4, I don't. Just because I don't feel like the function is increasing or decreasing at negative 4. And therefore, it starts decreasing at negative 4, and it decreases forever after that. Okay, Same information, but how do you do it when it's in transformation, or excuse me, when it's in standard form? Now, if you want to, this is entirely up to you. If you enjoy working in vertex form, take this and change it to vertex form and do exactly what you just did. Okay. What I'm showing you now is what if you really don't want to change it. I don't, because the way I'm going to do it now is just as quick. What if you don't want to change it to vertex form? Here's what you do. Is it opened up or down? Since it's positive there, that'd be opened up. So my parabola will look like this. My vertex should be the minimum point of that parabola. It's the lowest point. Next easiest thing to find was actually the axis of symmetry. That would be negative b over 2a. Here is b. That's negative negative 4 over 2 times 2, which is 4. Your axis of symmetry, if you want to call it your A of S, your axis of symmetry is x equals 1. So therefore your vertex will be 1 comma something because the axis of symmetry passes through the vertex. In order to find the y value that goes with that 1, simply plug that plug the 1 in for the x's. That gives you 2 minus 4 minus 9, which I believe is negative 11. So there's your vertex. Let's see, so we've got, it opens, we got the opening, we got the vertex, we have the axis of symmetry, the range. The range starts here and goes up. You have to have a starting point and an ending point. Range is your output values. That's your y values. The y values start at where, Logan? What's this y value here? Negative 11. There you go. That's the vertex is the lowest point, and I see where you got that negative 9. But that's going to be something different, actually. Negative 11 is the lowest point on your graph, so my range is all the values from, including, because that vertex is on your parabola, negative 11 up to positive infinity. That's the range. Done. Maximum or minimum value. This parabola, since it cups up, has a minimum value, and that minimum value is, again, negative 11. That's the lowest point. That's the lowest y value of your function. Done with that. Maximum or minimum. The intervals where the function is increasing or decreasing. Increasing, decreasing. And again, these intervals are over the x's. If you question why you use x's for where it's increasing or decreasing, try to use the y sometime. Oh, it's increasing from negative 11 up. Okay, where's it decreasing? Negative 11 up. It just doesn't work out. Does that make sense? Because this is negative 11, and if I ask you where's it increasing or decreasing, well, that would be the same places you just gave me. So that's the reason we use our x values. We're traveling from left to right. We're decreasing everywhere up to this point. So that'd be decreasing from negative infinity up to this x value of the vertex, which is 1. And then we start increasing at 1, and we go to infinity. That's where it's increasing and decreasing. The last thing that you might have to tell me about the parabola is where is its y-intercepts and where is its x-intercepts. If you remember back a couple of chapters ago, I told you how to find y-intercepts and x-intercepts. This information we'll use, again, the rest of the semester. In order to find a y-intercept, Skylar, do you remember how to do it? What do you do with x? Make it 0. To find a y-intercept, you make x 0. To find an x-intercept, you make y 0. That's all you do. Okay? At a y-intercept, x is 0. At an x-intercept, y is 0. And a lot of people's like, well, why is it backwards like that? Guys, you're taking out the x. Okay? If I take out all the x's and put in zeros, you're going to be left with y equals something. That is your y-intercept. If you take out the y, you're going to be left with x equals something. That's your x-intercept. So let's find the y-intercept first, just because it's easier. To find your y-intercept, this x value right here, make it 0. So you have negative 2 times 4 squared minus 8. Here's where people miss this problem. Make sure you do not do negative 2 times 4 first. The negative 2 is not being squared. If you multiply these, it will be squared. Okay? The only thing being squared here is the stuff in parentheses, which is the 4. So that's negative 2 times 16 minus 8, which is negative 40. So your y-intercept is 0, comma, negative 40. Your x-intercept. In order to find an x-intercept, plug in 0 for y. 0 equals negative 2 times x plus 4 squared minus 8. Okay, let me caution you. Let me save you some time here. A lot of people's going to want to square that out. Well, number one, there's a good possibility when you square it out you're going to forget and you're going to write this as x squared plus 16. This is not x squared plus 16. If you square it, you're going to have to FOIL it. But you're creating more trouble for yourself than it's worth. Don't do that. Okay? Here's all you've got to do. In order to solve this, take this minus 8 and take this minus 2 and move them over here. The minus 8 you're going to have to move first because it's being added or subtracted. Then we'll divide. Since this is being multiplied, we'll divide by negative 2. So minus 8, when you move it, let's cheat. Or here we go. That's an 8 now. Minus 8 turns into positive 8, but then we have to divide by negative 2, and I now have negative 4 is equal to x plus 4 squared. And hopefully you already see a problem with that. It's going to be really hard to square something to give me a negative. So right off the bat, do you know what the x-intercepts are? Non-existent. There are no x-intercepts here. How can that be possible, though? If you have a parabola, which, by the way, this parabola opens downward, how in the world can you have a parabola and not have an x-intercept? Well, the tip there would have been if negative 4, negative 8 is your vertex, negative 4, negative 8, that's somewhere down here. And this parabola opened up or down? Down. Is that going to cross the x-axis? That makes sense. You're not going to have an x-intercept. If you do, here we go. This is just for review. If you do want to find out, there's no real x-intercepts, but if you want to find the imaginary answers to this, what do they mean, honestly? I don't know. But if you would like to find these imaginary answers, to get rid of a square, you're going to square root. The square root of negative 4 is the square root of negative 1 times the square root of 4, which is 2i, equals, actually it's going to be plus and minus 2i, equals x plus 4. Because when you square, you got to do plus and minus. To get rid of a square, you plus and minus square root. To get rid of the minus plus 4, you're going to do minus 4. So your two complex roots would be negative 4 plus 2i and negative 4 minus 2i. But as far as where is it going to cross, it doesn't, because it does not have real roots. The next one, and probably the last one, we probably won't get into the inequalities today. What if you're given it in this form? How do you find the x and y intercepts now? Well, if you'd like to write it in vertex form, go for it. To get this in vertex form, you'd complete the square, do all that. The only problem is you'd move the 9 over, you'd have to factor the 2 out, lots of don't do that. To find an x-intercept, plug in 0 for y. To find a y-intercept, plug in 0 for x. Now, y-intercept, y equals whatever. Plug in, and when it's in this form, plugging in 0 for x, watch how easy this is. That goes away and that goes away. There it is. Negative 9. Because when you plug in 0 for x, the other two things go away. So do you see the similarities between that and a line? This is a quadratic equation, which again is a parabola. If you took this quadratic piece away, does everybody see that that's a line? Negative 4x minus 9. Well, how do you find the y-intercept of that line? Well, that would be in y equals mx plus b form. This is the slope, this is the y-intercept. Why is that the y-intercept? Because when you plug in 0 for x, that goes away. So parabolas work the same way. If a parabola is in vertex form, whatever's being added or subtracted at the end, that's your y-intercept every time. Now, x-intercept's not so easy. To find an x-intercept, plug in 0 for y, so I have 2x squared minus 4x minus 9 equals, plug in 0 for y. So please know the connection here. The solution to this quadratic equation is the x-intercepts, and we'll go ahead and throw some terminology in here. It's the x-intercepts of this parabola, which is also known as the roots of that parabola, or the zeros of that parabola. Those three words or terms are used interchangeably. So if I ask you to find the x-intercepts, the roots, or the zeros, I mean the same thing. Just going ahead and knocking that out early. So let's look for the roots, let's look for the x-intercepts, let's look for the zeros. Okay, 2x squared minus 4x minus 9. It's got a 2 out front. We got to solve this quadratic equation. You solve it by factoring, completing the square, quadratic formula. We're going to try to factor. Since there's a number out front, we got to use what's called bottoms-up factoring. X squared minus 4x minus 18 equals 0. What adds to give me negative 4 and multiplies to give me negative 18? Anybody know? Nothing. Nothing does. So what does that tell you about this problem? It cannot be factored. What does that tell you? If it cannot be factored, your roots, your zeros, your x-intercepts are not going to be nice, clean x-intercepts. The next best method, let's use quadratic formula. X equals negative b plus and minus the square root of b squared minus 4ac all over 2a. And I encourage you to go ahead and do b squared minus 4ac first. Just because, for this reason. If you get a negative number right here, you could stop. If b squared minus 4ac is a negative number, that means that this parabola has no x-intercepts, no real x-intercepts. I think this one probably will. B squared, that's negative 4 squared, which is 16, minus 4 times 2 times negative 9 is a negative 72, I believe that's right. Minus minus is a plus, you get 88. Yeah. So we're gonna have some roots. Here's what your roots are. Negative b plus and minus the square root of 88. Clean that up. Anybody see any perfect roots in 88? There's only one. What is it? Good. 4. So it's 4 times 22, which will be 2 root 22. The square root of 4, I know, it's 2. Over 2 times 2 is 4. That's right, but it's not cleaned up yet. And we're going to look at it both ways. Okay, clean up. There's 3 terms here. I just go through and divide everything by 2. Okay, that's going to be about the best way to clean it up. So instead of 4, divide this by 2, divide this by 2, divide this by 2. That would be 2 plus and minus the square root of 22 over 2. Just a lot of 2's. Those are your x-intercepts, and to be quite honest with you, that means absolutely nothing to me. Where in the world is that? Right. But I'll tell you one thing it does do for you. Once you have this, remember what I told you about the quadratic formula a while ago? Negative b over 2a, that first part is the axis of symmetry. You see what your axis of symmetry is? If you're looking for the zeros first, you can find your axis of symmetry just by doing 4 over 4. It's 1. Because think of it. Okay, if you split this up, your axis of symmetry is going to be right in the middle. Your zeros are going to be that axis of symmetry plus some number, and the axis of symmetry minus that same number because it's symmetrical. That's where your y or your x-intercepts will be located. Some set distance from the axis of symmetry to the right, and that same set distance from the axis of symmetry to the left. So now, again, this means nothing to me. This would mean more. The approximate values. Let me pull up my calculator. The actual zeros of this quadratic will be, and I'm going to put the top in parentheses so it'll divide the whole thing by 2. You've got 2 plus the square root of 22, close parentheses twice, divided by 2. That's about 3.35. Or, again, here's your hint, tip for the day, calculator tip. I don't want to type all that in again because it's the same stuff. I just got to change that to a minus because it was 2 plus or minus square root of 22 over 2. Above your enter key, you have what's called entry. Did I show you all this the other day? Above enter, you have entry. Do second enter, and it puts that last entry back in there for you. So now you can just scroll over and put minus in the place of plus, and you get negative 1.35. Those are your two x-intercepts. Means your parabola crosses at negative 1.35 and 3.35. It's going to look something like this. You could find the vertex very easy by doing negative b over 2a. You can find the axis symmetry and all that. But we've already told you what the axis symmetry is. It's right there. It's 1. Look at these two answers. If this is x equals 1, how do you get from there to there? Look at the difference. Looks like you add 2.35. Well, what if you take that and you subtract 2.35? You get the other one. That's what an axis of symmetry is. It cuts it into two symmetrical pieces. Add 2.35, subtract 2.35. That gives you the two x-intercepts.